Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SMSCT. So today I'm here to discuss about the lecture series on electronic circuits, and the topic which I'm going to discuss here is about the PN junction diode operation. So we all know that the very basic and fundamental semiconductor device is our PN junction device, PN junction diode, which is widely used in the electronic circuits. So from the name itself, it is understood that it is a junction between P-type and N-type semiconductor material. Hence the name PN junction. So here you could see a P-type silicon and an N-type silicon is taken, and when it is joined together, we get a PN junction. So hence the name PN junction diode. So this is the symbol for PN junction diode. It has two terminals. So one is anode, which is a positive terminal, one is cathode, which is a negative terminal. So this is the PN junction diode. So why we have two device? So this is a fundamental device which is essential in every electronic circuits, which is a semiconductor device. So why we are learning this devices, it is widely used in many applications like rectifiers, voltage regulators, and signal detectors. So rectifier, so we all know the term rectifier, so which is used to convert AC into DC. So we have discussed about this rectifiers in the previous session. So rectifiers are the device which converts AC into DC, which means that the unique property of the diode is that which allows current to flow in only one direction. So that makes the diode to work as a rectifier. And then it is acting as a voltage regulator. So which means that most of the electronic devices requires regulated DC power supply. So that can be achieved with the help of our diode, which is acting as a voltage regulators and also in signal detectors. So these are the areas where we use our PN junction diode. So first, let us discuss about the construction of PN junction diode, how it is being constructed. So a P-type material is taken and N-type material is taken, and when it is joined together, so there forms a junction which is called PN junction. So we know that the P-type material has an excess of positively charged holes, whereas the N-type material is having excess of negatively charged electrons. So when both are brought together without any application of external field, as per Coulomb's law, so we know that opposite charges attracts and the like charges repels. So when they are brought together, diffusion occurs here. So what happens here is in P-type, we have majority of holes, whereas in N-type, we have majority of electrons. So the electrons from N-type move towards P-type and the holes from P-type move towards N-type. So due to the force of attraction. So after certain time, what happens? The N-type will have a net positive charge and the P-type will have a net negative charge. So at this stage, the movement stops and a depletion region will be formed which contains immobile ions. So further, there will not be any movement of charged particles between two regions. So that particular part we call it as depletion region, which contains immobile ions. So here is the picture of how depletion region is formed. So when these materials are brought together, electron from N-type diffuse into P-type and holes from P-type diffuse into N-type. So diffusion occurs and it creates a region near the junction with the depletion of charge carriers. So the name depletion means here it is depleted of charge carriers, which means further movement of this ion does not occur. It contains only immobile charges. Hence the name depletion region. So this is how the depletion region is formed. So you could see that most of the P region has the electrons here. The N region is having the holes which is being diffused here. And at particular stage, a depletion region is formed. So this creates a the electric field that opposes the diffusion of any further charge carriers across the junction. So that potential barrier is acting as a one-way wall for the flow of electric current. So that depletion region is formed, as I told, which contains immobile ions, which means that here the barrier potential is created, which further blocks the movement of this charge carriers. So now let us discuss the working of PN junction diode in a forward bias. So when a forward bias is applied, that is when positive connected to the anode, negative connected to cathode. So positive to positive, negative to negative is called forward bias. When this forward bias is applied, what happens is the potential barrier is reduced and electrons can flow from the N-type material to the P-type material, and that is called as forward current. So here we could see that the depletion region is thin. Okay, so when a forward bias is applied, depletion region reduces, it becomes thin, and there exists a forward current. So this is the operation of forward bias. Whereas when we connect these two regions with reverse bias, when a reverse potential is applied, here what happens? So when the positive is connected to negative and here a negative is connected to positive. So when this type of reverse bias is applied, the potential barrier is increased. We could see that here there is an increase in the depletion region. So the flow of electrons is inhibited, and this contributes to a very small reverse current. So this is the operation of this diode in reverse bias. So today's assessment, PN junction diode is a fundamental semiconductor device, so which is the essential element of the electronic circuits. So depletion region will create a potential barrier that opposes the diffusion of any further charge carriers across the junction. So for first one, it is the semiconductor, and second one, it is the potential barrier. And when a forward bias is applied to the diode, potential barrier is reduced and electrons can flow from N-type to P-type material, which is called as forward current. So thank you all.